jumping. We talked about base jumping and skydiving. And so I'm going to quickly kind of go through we're going to kind of speed through the PowerPoint that we did on Tuesday and get to the new stuff. But the PowerPoint is posted on Schoology. So let me see. Hold on. I have two keyboards, you guys, so sometimes I'm typing on the wrong one. All right, so let me see. I'm going to turn on this camera and I'm going to share my screen. Let's do presentation. And then let's go back and share screen. I'm trying to make sure I'm recording, but I'm not really sure. I think I'm recording, and I think, oh, there it goes. Okay, so here we go. Yes. All right, so we were talking about kinematics, but we haven't really talked about what that means yet, but we're gonna talk about that today. But it's very easy. It just sounds like a really complicated long word, but it really isn't. All right. So just making sure you guys can see what I see. So we talked about skydiving, and am I not sharing? Oh, there it goes. Okay. I was trying to make sure I'm seeing the same thing. So we talked about skydiving and base jumping. So skydiving, they get in the plane and then they jump out of the plane, and then they like when they first jump out of the plane, they free fall, which just means they're not doing anything, and then eventually they pull their parachute. And then remember, base jumping was like they would get on top of these buildings and stuff, and they would like just jump off of like a building or a bridge or an antenna, and it looked super crazy. But you know, like half of the class said, well, it wasn't half. It probably was about a quarter to a third of the class said they would do both. And I said I wouldn't do either one. I'm not jumping out of a plane, a perfectly good working plane. No, thank you. I'm not jumping out of a plane. I'm not jumping off a building either. So we did go through that. And then we saw that cool video where the guy dropped it. And then we were trying to decide, was the ball falling at a constant velocity, so like the same speed all the way down, or as it started to fall down, did it start to speed up, or the fancy word for that be accelerate, right? And what did we decide? Did we decide, did it fall at a constant velocity or was it accelerating? Ricky, do you remember which one it was doing? Or anybody else? Where's Ricky?
Accelerating.
Yeah, it started accelerating. Very nice, Kevin. It started accelerating. And so when we looked at this picture, remember these lines were about 0.25 meters apart, I think. So at first you can see the ball kind of falling through, and then as it gets to the bottom, you see it's skipping a whole 0.25 meters because it's falling faster. Okay, it's falling faster. All right. So I don't know if we answered this question. Does anybody remember if we answered this question? Was it a positive or negative number? Did we answer this? We did? What did we say it was?
I think we said positive.
Did we say positive?
No team did that word. No team did.
Well, here's the thing. So on one hand, okay, I'm going to see if I can write on this. On one hand, I'm going to turn this so I can see you guys. Right? So on one hand, remember when we are accelerating, let me see if I can annotate here. Yes, draw, boom, great. Remember when we are accelerating, there's a couple of different things we can do. Can you guys see me writing on the screen? Like, can you see this? Somebody unmute and tell me.
Yeah.
Yes.
Okay, good. All right. So remember when you're accelerating, you can either, you can speed, oof, my writing. Let me try that again. I'm learning how to write on this board. You can either speed up, you can slow down, or you can change directions. Okay, so we would say typically that if the ball is falling down and it is accelerating, that's what it was doing, that it would be a positive number because it's speeding up. However, what we're going to learn today is we're actually going to make it a negative number. And it has nothing to do with the fact of the speed. It has to do with the fact which way it's going. So we're actually going to give this is actually going to end up being a negative number, but the negative, okay, the negative, this just means that it's going down. In physics, sometimes we're just talking about the direction. Okay, direction. So we're going to give it a negative number because it's going this way, not because it's slowing down. Okay. All right. So let's see. Let's go to the next slide here. Oh, I got to clear out my stuff here. All right. We talked about this. We talked about this being called free falling. Okay. And it just means nothing's acting on whatever is falling except for gravity. So if I had I don't know if you can see me, but if you can see me, can you guys see me or you just see like my screen?
Your screen.
Okay. So if you can, I think it depends on the device, but if you can't see me, if I was holding something and I dropped it, okay, nothing's acting on that but gravity. Okay, that's what free falling is. So when those people went skydiving and they first jumped out the plane, oh, I can do some art. Okay, so when this is, look how, oh, sorry, let me go back. Oh, I just dropped something. I'm okay, don't worry. All right, all right, so remember when those people were just jumping, okay, so they had a nice, oh my goodness, okay, there was an airplane. Look at my airplane, isn't this great? All right, and then the people were like, hey, let's jump out of the airplane. This guy goes, Geronimo, and he just jumps out of the plane. Remember at first, he jumps out the plane and, you know, he's kind of like floating like this, right? He's floating, he's free falling. And then after he goes down so far, he eventually opens his parachute. All right. This is why I teach science and not art. Okay. He opens his parachute, then he stops free falling. Okay. That is really bad art, by the way. I think my airplane looks pretty good though. Kind of looks like a submarine, but anyway.
Yeah, it looks like a costume.
My stick people are pretty good though. I'm pretty impressed with that. Okay. All right. So did we finish watching this entire video right here? Did we vote on this?
We did.
And then we watched the whole video, didn't we? Does anybody remember what happened?
I don't remember about the video, but I do know that we voted.
So if you don't remember, we watched this video, okay? And there was this guy, they had this big room, okay? They had a really big room, all right? Really, let's draw. All right, they had a really big room. Look at that, that's a good square. All right, and then they had this crane at the top of it. And on the crane, that was supposed to be a line. On this crane, they had the bowling ball hanging from it and they had the feather hanging from it, okay? And when they dropped it at the same time, okay, so people either told me either the bowling ball is gonna hit first, or some people said the feather and the bowling ball would hit at the same time, okay? So when they first did it, the bowling ball was like, and it hit the ground first, and then the feather kind of drifted down and eventually hit. But then when they sucked all the air out of the room, so then when they took out all the air, removed the air from the room, and there was nothing left except for that special force that pulls things towards the ground. Kevin, what's the special force that pulls things towards the ground? Starts with a G.
Gravity.
Gravity, very nice. When there was nothing there but gravity, they hit at the same time. It was kind of cool because you don't think of a bowling ball and a feather as moving at the same time.
How do you remove air from a room?
It is called a vacuum, okay? So it is, well, it's literally just like how a vacuum works. They literally can suck all of the air out of the room. They can get, it's almost minuscule. There's probably a little bit in there, but I'm talking about there's no air in the room, like the people can't even be in there because there's no oxygen.
Yeah, it's like an airtight bag when you like seal up meat.
Exactly. So yeah. So they removed the air. So the only thing acting in there was gravity. Because really, realistically, the feather, the only thing that was keeping the feather up was air. Like we don't think about it, like air's not holding me up. But realistically, if I was lighter, air could hold me up. That's what happened with the feather. Okay. All right. So let's see. So we watched that video. And then here are my drawings here. So here's where we are today. Okay. Now there's a lot of writing on this, but I'm going to tell you exactly what it means. Okay. So let's talk about what all this means. So it says the acceleration at the surface of the earth is a constant 9.8 meters per second squared toward the center of the earth. What that means is, okay, if you drop something, whatever you drop is going to fall down at a speed of 9.8 meters per second every second, okay? And here's the thing that I want you to note though. This happens, but this is specifically when you are, on Earth, okay? Because if I go somewhere else, if I go to the moon or I go to Saturn or I go to Jupiter, they have gravity, but the number is different, okay? Or some places, the gravity may be so light you're not falling at all, or you're floating like in outer space, okay? Now, this part in blue is just saying when we're doing our calculations, we're not gonna think about air resistance, which is what was pushing not pushing, but causing the feather to fall slowly, okay? And we're not gonna think about elevation. So for instance, they're saying if gravity is at the center of the earth, well, what happens if I'm at the top of the mountain versus being closer to the center of the earth, like I'm at a beach, okay? So for all purposes, we're not gonna think about any of that stuff. Now, here's that part I was telling you about where we use this negative right here. This does not mean you can't have a negative speed, right? I can't get pulled over by the police officer because I was going negative 75 miles per hour. Like that doesn't even make sense, okay? This negative specifically is telling me which way I'm going. So this negative just means moving down. Okay, and that's what this next part is going to say. Okay, so that's what that means. Negative sign tells me the direction. It just means that I'm going down. Okay. All right, I know I've been talking a lot. Everybody kind of okay so far? So basically, all we need to know is this number. We're gonna, I'll give it to you, but this is the number. Oops. Let me go back. Sorry. There we go. This number is the number that we're going to want to remember. This is why I want you to remember from the slide. This is the number we want to remember. And this negative sign means that we're going down. It just means that we're moving down.
Can we note
So
this
I'll
down?
tell you, Joe and I are particularly.
Do we write it down?
The cold is.
No, well, you have this power and no, you don't have to write it down.
Okay.
Because you have a set of notes let me show you where your notes are. You guys have, remember I told you if you can in Schoology, there was something that said kinematics notes. Let me show you what they look like. Let's do a new share.
500.
New share. All right. So if you go into your kinematics folder, okay, there's something right here that says kinematics notes. Let's see. This says kinematics notes right here. You guys see that? Okay.
Yeah.
Open it. When you open it, it looks like, I'll show you. Oops, let me go back to my mouse. It looks like, hold on, physics. It's gonna open this right here for you. Let's see. Right, it's gonna open this right here for you. So,
Where do I find it?
say again.
Where do I find it?
It is right here in the physics. So you can either go to the physics classroom and click today's lesson, or you can go into the folder that says 1D, 2D motion. And then right here it says kinematic notes. Okay. Now,
And then we fill it in for today.
say again.
Then we fill it in for today.
Yeah, so the part that we're about to get to right now in the PowerPoint. So right now, this sheet right here, once you get that, once you click that, it's gonna open this for you, okay? This sheet is gonna follow the rest of the PowerPoint. So when you see something in red on the PowerPoint, like for instance, right now, this says, kinematics equations can only be used when we have blank, okay? So everybody see that? Now, when I go back into the PowerPoint, share, share. When I go back into the PowerPoint and we go to the next slide, look at that. Kinematic equations can only be used when we have, and I was very nice, and I actually color coded for you, constant acceleration. So that's what you would put in your notes. Okay.
Okay.
Cool. All right. So kinematic equations can only be used when we have constant acceleration. Okay. All freely falling objects, okay, and that's anything that we drop or throw down, okay, have a constant acceleration in the downward direction, which means this is the number that we're going to be using for it, okay? Now, it says, or projectiles. We're not going to talk about projectiles just yet, but I'll tell you what they are. It's basically anything you shoot into the air, okay? So if you, or shoot, even if you shoot it straight across, okay? So if you shoot a rocket, a gun, a cannonball, you launch a paper airplane, even if you shoot it this way, what eventually is going to happen? Eventually it is going to fall down, okay? That's what a projectile is. So even when they launch the rocket ships, right? Even if they launch it up, it eventually will have to come back down, okay? That's what a projectile is. All right.
So you said it's an acceleration and then kinematic.
Yes, so it's going to accelerate up until, and that's what we're going to be talking about over the next week, until the force of gravity overtakes it and pulls it back down. So that's what we're trying to figure out. Sometimes we're trying to figure out, okay, well, if I shoot this up, how long does it take for it to fall back down? Or if I drop this, how long before it hits the ground? Or what speed was it going when it hit the ground? So that's what we're getting into now. We're talking mathematics. We're saying, okay, Yes, go
The
ahead. Sorry.
constant,
Say
the
again.
constant acceleration is 9.81 ms2.
You got it. That's correct. That is correct.
Miss Peyton,
Yes.
how come we said in physics down is negative, but then it says they have a constant acceleration in the downward direction?
Mm-hmm. So it's just telling you, so it's trying to explain to you that, hey, when we use that negative, we're not saying it's a negative number. It's just saying, hey, this stuff is going down. So it's not like how we could say like -3 and think about on a number line, it's like an actual number 3, or sorry, -3. I'm saying number by negative. It's not saying, so when we say negative, usually when we say negative acceleration, we think something is slowing down, okay? But when we're talking about kinematics, when we're talking about dropping stuff or throwing stuff, it's just telling us like, hey, you're gonna throw this or you're gonna drop it. The negative is just telling me that it's going down. It doesn't have to necessarily do with the speed.
Got it. Okay.
Yes.
Thank you.
So it's just for the direction. Because otherwise, if there's not a negative in, not a negative, we assume it's going like a car driving straight forward, or it's going straight up. That's what we're thinking.
So when we're filling in the columns, like the one that says starts from rest, what it actually means? What are we supposed to put there?
Got to that part of the presentation yet. I'm moving there.
Okay.
So right now, if you are doing your notes, you should have filled in this constant acceleration part. And then down here where it says warning, says don't forget to include a negative sign or something like that. So let me pull up my notes so I can just see what they look like. So I can make sure I'm following along with you guys. Let me. Oh, wrong one. Right. All right, yes. So they already have the negative sign in your notes. All right, so now we're on the next slide. So Esther was asking about the part that's on the next slide. So let's go to the next slide. Mouse. Let me clear. All right, so now we're not quite there yet, Esther, but I'm going to tell you about it. So let me just show you these equations, especially compared to like what we used to do, which was like, remember, this is what we were doing. We were doing stuff like S is equal to D over T, right? The most complicated one we had got was acceleration, and that was VF minus VI over T. So now we have these, okay? I do not want you to be intimidated by them, okay? I'm gonna give you most of the numbers. We're gonna solve for one, and we're gonna take it very slow, okay? So when we're looking at these, we have D, which is displacement, okay? And these are two different equations, okay? So it depends on what you're looking for. And that's what we're gonna get into next week as a practice. I just wanna introduce the equations to you, okay? We remember VI and VF. So remember VI was your starting velocity, okay? And then we had VF, and that was your final or ending velocity, okay? So, and we've had A before. We've already had A, which was acceleration. And we've also had T. We already had T too. T was time because we had T over here, okay? So the only new letter we really got, which we've done before, we just didn't use it in an equation. Oh, yes, we have. D, displacement. We've done that too, because it was over here. Really, it was kind of distance, the same thing. Now, I do want to make a note though. So let's just look at how you would put numbers in the calculator just for a second, okay? All right, so if I were solving for D on here, notice if I'm looking at this box right here, this part of the equation, okay, there's a VI and there's a T. Somebody tell me mathematically what am I supposed to be doing with that? There's no VIT over here. There's a VI and a T. What am I supposed to be doing with those?
Multiply.
Multiplying.
I'm supposed to multiply. So this what this really means is VI, okay? And then that means I would multiply it by T, okay? All right. And then over here, okay, if you want to on your notes, you can make a note, because like writing 1 divided by 2 in your calculator or half in your calculator can be tricky sometimes. If you want to, 1/2 is the same thing as saying 0.5. Those are the same thing, okay? So you can say 0.5. Now, anybody know why, to me, it's not tricky, but why you have to be extra careful right here? You might know why you got to be extra careful right here.
You have to use PEMDAS.
Very nice. You got to use PEMDAS. Excelente, Eric. PEMDAS. PEMDAS. All right. If you don't know what PEMDAS is, it tells us our order of operations when we're doing math. Okay. So this is parentheses. This is exponents. And exponents are those tiny numbers like this one right here. This is multiply. This is divide. Okay, this is add, and this is subtract. Okay, so when we get ready to do this A, and then we're going to do just like we said before, we're going to have to multiply it by T. What color did I do for T? Blue. All right. What we have to do before we multiply those is make sure we square T first. Okay. So when we get ready to do this, whenever we do our calculations, we square this part first, then we multiply it by 8. Okay. All right. So there's going to be a couple of different equations. I will always give you equations. Okay. But let's talk about how we would solve them. Okay. And we solve them differently. We don't solve them differently, but we use certain equations depending on what we're looking for. Because like if you look at these two equations, somebody tell me something that is, tell me, what do you see in, oops, sorry. What did I just do? Oh, let me go back. Nope, wrong way. Here we go. What do you see, okay, in, oh my goodness. All right, let's try this again. Let me see. Oh, sorry. I'm sorry, guys. I'm so sorry. I'm not supposed to lose it in the middle of class. Spotlight. Okay, I give up. Tell me, what do you see in the first equation that you do not see in the second equation? Is there a letter you see?
The squared.
Squared, and what else? So what about a letter?
Displacement is in the second one, and it's, well, I mean, it's in the first one too, but it's what the formula is equal to.
So is there something in the first one that's not in the second one? I think I heard someone say it.
Is it time?
Yes, it is time. Okay, so if you see in the first equation, there's no time. In the second equation, I'm sorry, in the first equation, there is time. In the second one, there's not. Okay. All right, we're almost done for the day, guys. A few more minutes. So let's see. All right. Now I wanted to change it. It won't change it. There we go. All right, so this is, now we are on the notes part that Esther was asking about. So if you're on your notes, it says steps to solving a problem. All right. And realistically, we're going to finish with this today, but realistically, this is no different than what we've already been doing. Okay. No different than what we've already been doing. Okay. So it says list your knowns and unknowns. Okay, so I'm going to show you exactly how we did this when we did the speed one. Okay, so when we did speed, we did the same thing. We would write our equation, S is equal to D over T. And then we would list our knowns and unknowns. So we would say S is equal to, D is equal to, T is equal to, and then we would read our problem. And if we had a number for D, we put it right here. If we had a number for T, we put it for here. And if we didn't know S, we just left it blank, or we put an S, or maybe we put an X, okay? So that's listing our knowns and our unknowns, all right? Then we have to compare it to the formulas. So if I see that it gave me a time and my equation doesn't have time, I can't use that one. So that's all that is, all right? We'll start learning how to draw diagrams. Like if they say they shot it up, we'll just draw an arrow going up. If they say it went to the right, we'll draw an arrow going to the right. Then we'll go back and plug in our numbers just like we used to do. We go back and take this number and this number, and we would plug it back in, this one here and this one here. And then we are going to solve, okay? All right, so this is just telling us how to do that. All right, let's get one more slide and we'll be done. One more slide, okay? Why is everyone leaving? We're almost done. Oh, maybe it's just the same person who kicked out. All right, last thing for the day, super easy. All right, clear all drawings. All right, so now the last thing, helpful hints, okay? And on your sheet, let's see if they are not filled in. So remember, we've talked about this before. If it starts from rest, that's not unusual. We will talk about how that meant that VI was equal to 0, right? We did that before. Or if it came to a stop, then we knew that VF was equal to 0. So the only new one really is that if we I'm so glad today's Friday, you guys. So glad. I love technology. I love it. I love it. Draw, click. Here we go. Dropped is the only new one right here, okay? And if we see dropped or starts from rest, then VI is equal to 0. If it comes to a stop, VF is equal to 0, okay? And if it says that it is, you see something about it falling or something related to gravity or some type of projectile, like I shot this into the air, okay, like this, then we know that A is equal to 9.8 meters per second. And we know that what goes up must come down, okay? All right, any questions? We haven't started doing work. I'm trying to go very slow before we actually get into it because I want you to understand what these.
I have a question.
Yes.
Sure. Where do we put those words?
So the one, so if you look on your sheet, the stuff that is in red right here is missing. So on your sheet, you see starts from rest and you see dropped, but this is not there. So you're just writing in this.
Could you show the previous one?
The previous slide, or you mean the notes?
The previous slide to see the missing ones.
Oh, yeah, sure. Here. Mouse. This one?
Oh, yeah.
Okay.
Are those the only ones?
Yes, they go right with your notes. So they are two on your notes. Here, I'll even, if you can, guys, I can see my screen. It is on the right side of those boxes. Okay.
Wait.
Yes.
What about the formulas?
We just didn't get there yet. We're going slow. We're going
Okay.
slow. Okay. All right. Any other final questions?
Was there anything this week that was good?
Nothing too yet. We're going very slow. Nothing yet. Okay, so have a lovely weekend. I will see you guys on Tuesday. Okay.
Bye.
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 Bye, guys.
Bye, Miss Hayden.
Bye, Eric. Thanks, Hayden.
Bye, Rick.
Have a great weekend.
You too. Bye, guys. Pamela. See ya.